Hey everyone, in this video lecture we will be discussing about the irrational numbers. We will be learning about few of the theorems and we will also solve a few questions based on them. Okay, so as I explained you earlier, what are irrational numbers? Irrational numbers are those numbers which cannot be represented in the form of p by q. Which cannot be represented in the form of p by q, all those numbers are known as irrational numbers. Where p and q are some integers and q can never be equal to 0. Q is not equal to 0 and where p and q are some integers. The examples of irrational numbers were like, if I take 0.1200, 1 to 000, 1 to 5 zeros, and so on. It keeps on continuing. Okay, so here there is no repetition, like we cannot get any repeating values for these digits, so we cannot put any bar sign, and this is why it cannot be represented in the form of p by q. We cannot represent in the form of p by q, and that is why this is an irrational number. Now coming to the theorem. Okay, so the theorem is, let p be a prime number if let p be a prime number. Okay, we are considering p as a prime number. Okay, if p divides a square, okay, if p divides a square, then p divides a, where a is a positive integer. So basically what this theorem explains is that, I will give you some example, then it will be very clear to you. Let, assuming p is equals to 3, we have assumed that the value of p is equals to 3, and we have assumed that the value of a is equals to 9. Okay, it is given that if p is a prime number, of course 3 is a prime number, we have assumed it like that only. If p divides a square, now what will be a square? Means 9 square, that will be equals to 81. Means if p divides 81 or if p divides 9 square, then p divides a. Means if p divides 9 square, then definitely if p divides 9 square, then definitely p will also divide 9. Okay, this is what this theorem explains, where a is some positive integer. Of course we have considered a as some positive integer only. Now moving to the questions part. So now we have to prove that root 2 is irrational. Okay, you'll have to prove that this root 2 is irrational number. So how will you prove? We will prove it by contradiction method. How we will prove? We will prove it by contradiction method. Okay, so now what is this contradiction method? We will assume that this root 2 is rational. We will suppose that root 2 is rational. Now, if this root 2 is rational, then it can be easily represented in the form of p by q or a by b, anything that you consider. Okay, then we assume that this root 2 can be written as a by b. Okay, since this is a rational number that we have assumed, where b cannot be equal to 0. This is our assumption. Now, one more thing that you have to keep in your mind is that whenever you write any number that is root 2, we are writing it in the form of a by b. That means here a and b are in the simplest form. Okay, now means we don't have simplest form means we don't have any common factor between a and b anymore, because these two numbers are in simplest form. So if you don't have any common factor between them, then those two numbers will be co-prime. Okay, so till now, as we have assumed that root 2 is rational, so it can be easily represented in the form of a by b, where b is not equals to 0, and this a by b is in the simplest form. That means we don't have any factor for a and b, and that is why it is a co-prime. This a and b are co-primes. Okay, now you can easily write now that since step number 2, we are coming to step number 2 now. Here you can write, since we have assumed that root 2 is equals to a by b, as it is a rational number, so from here you can write root 2b will be equals to a. You can write it like this. Okay, now if you square on both sides of this equation, if you square on both sides, you will get 2b square will be equals to a square. Okay, that means you can write that this 2 is a factor of a square. We can write that this 2 is a factor of a square. And by fundamental theorem, now you can also tell that this 2 is a factor of a. You can also tell that since 2 is a factor of a square, therefore by fundamental theorem 2 is a factor of a. Now since we have assumed that this 2 is a factor of a, so the factors of a can be many more numbers other than 2. This a must contain some other factors, so we are assuming that factor as c. So a, step number 4, I am writing it over here. So a can be assumed as, since this 2 is a factor, 2 into some other factor also must be there, so we are assuming it as c. So now substituting a is equals to 2c in this equation. Okay, so how will you write it down now? So you can write it as 2b square is equals to 2c whole square, that will give you 4c square. That means 2b square will give you 4c square. This is step number 5. Now coming to step number 6, you can write here as, since 2b square is equals to 4c square, so cancelling them out, like you can write here as b square will be equals to 4c square by 2. Taking this 2 down, so this will give you 2c square. This is step number 6. So we got that this b square and is equals to 2c square. That is what you can write it here as, this 2 is a factor of b. You can write it like that, because b square is equals to 2c square, means the square of the numbers are equal. That means this 2 is a factor of this 2 is a factor of b square, and that is why this 2 is also a factor of b. We can write it over here. So coming to step number 7, I am writing step number 7 over here. So here you will get that since 2 is a factor of b square, so by fundamental arithmetic theorem you can write that 2 is a factor of b. Okay, so it's very clear till here. Now coming to step number 8. Okay, now in step number 8 we will notice one thing, that in step number 3 and in step number 7, what we have noticed that 2 is a factor of b and this 2 is also a factor of a. That means in step number 8 you will write that from 3 and 7, means from step number 3 and from step number 7 we can write that 2 is a common factor of both a and b. So this is our contradiction. See what we have assumed, that root 2 is equals to a by b, means a and b are co-prime numbers, that we have already assumed, and co-prime numbers means they don't have any common factors. These two numbers are in simplest form, they don't have any other common factor. That is what co-prime numbers actually are. But here this is our contradiction. This is giving us a contradiction, that here we are getting 2 as a common factor of a and b. Okay, so actually then this results that our assumption was wrong. The assumption that we assumed in our first step, that assumption was only wrong. So what we assumed, that 2 is a rational number. So our assumption was wrong, and this root 2 is therefore an irrational number. So how will you write? So it contradicts our assumption and root 2 is irrational. Okay, so this is how you will prove any number to be irrational. Okay, now this root value can change from question to question, but this complete process of proof will be same. This process of proof will remain same for every values of irrational number that we need to prove, but like this value may change. This may be given you as root 3, root 5 or root 7 or anything you can be given, but this by this contradiction method only we will be proving it out. Okay, so moving on to the next question. Here again you have been given that root 3 is irrational, so you have to prove that root 3 is irrational. So we will be moving in the same steps. Okay, assuming root 3 is rational. Okay, and if you assume root 3 to be rational, then you will get root 3 will be equals to a by b, where b is not equals to 0 and a and b are co-prime, because they are in simplest form and therefore they don't have any other common factor, and that is why they are co-prime. So since root 3 is equals to a by b, so we can write root 3b is equals to a. Now moving on to the third step, squaring on both sides, you will get 3b square will be equals to a square. Okay, therefore we can write that 3 is a factor of a. This 3 is a factor of a square. So now fundamental theorem, by fundamental theorem you can now again write that therefore since this is a factor of a square, so therefore 3 is a factor of a. This can also be written. Now moving on to step 4, substituting now a. Okay, now we can write that since 3 is a factor of a, so the factors of 3 can be 3 is always there, since 3 is a factor of a, so 3 is always there, and with 3 there can be some other number as well, so that number we are assuming it as c. Now this a is equals to 3c, we are substituting it in this equation, so what you will get, you will get it as 3b square is equals to 3c whole square. Okay, so that will give you the result as 3b square will be equals to 9c square. Like this is what you will get. Okay, so now moving on to step number 5. What you will get in step number 5? So we can write it here that b square, okay, this is what we are writing, 3b square, I am copying it again over here, is equals to 9c square. So from here you can write b square will be equals to 9c square by 3, taking this 3 down, so that will give you 3c square. Okay, so it is clear till here. That is why we can write here that this 3 is a factor of b square. Therefore, 3 is a factor of b square. And that is why you can again write that this 3 is also a factor of b by again fundamental theorem of arithmetic. So, here we have written it. Now, coming to step number 6. Now in step number 6, what we will see, that from step number 3 and from step number 5, what we have seen, we have noticed, we have once written that this 3 is a factor of a, and we have again written that this 3 is a factor of b. So this contradicts our assumption. So how we will write? We will write that from step number 3 and 5, we have seen that 3 is a common factor of both a and b. And this contradicts our assumption, because our assumption was that a and b are co-prime. That means a and b does not have any other common factor. So it contradicts our assumption. And therefore, this root 3 is irrational. Okay, moving on to the next question. So before moving to our next question, we will go through two basic points that you have already learned in class 9th, and those are the sum or difference of rational and irrational number is irrational. Means if you add one rational and irrational number, you will get the sum as irrational. If you subtract rational number and irrational number, you will get an irrational number. So the sum, if you add one rational number and one irrational number, you will get irrational number as a result. If you subtract one rational number, one irrational number from a rational number, or the either way round, then you will get one irrational number again. The next point is the product and quotient of a non-zero rational and irrational number is irrational. Same way, if you divide one rational and irrational number, you will get the product and quotient as irrational itself. Okay, now moving to the questions part. Now again, you have to show that 5 minus root 3 is irrational. So the same way that we were proving, we will move in the same way. We will assume that this 5 minus root 3 to be rational. We have assumed, okay, assuming this 5 minus root 3 to be rational. So if 5 minus root 3 is rational, then it can easily be represented in the form of a by b, right? We can write it like this. So now from here you can write that 5, taking this a minus b to the left hand side and this root 3 to the right hand side. So 5 minus a by b will give you root 3, right? So from here you can write again that rearranging, we are just rearranging it. So root 3 will be equals to 5 minus a by b, and now taking the LCM you will get b, 5b minus a. Now here we know that this a and b are actually integers. So if these are integers, so you will get this complete number to be rational, right? A minus b are, if this a and b are integers, then this complete result will give you rational number. But as per our derivation, it was like root 3 is equals to this thing, 5b minus a by b. So if this is rational, this root 3 should also be rational. But we know that root 3 is irrational. That root 3 is irrational. Therefore, our assumption was wrong, and this 5 minus root 3 is not rational, it's rather irrational. Therefore, our assumption was wrong and 5 minus root 3 is irrational. Same way, we will go for the next question as well. You have to prove here that 3 root 2 is irrational. So in step 1, we will do our assumption that assuming 3 root 2 is rational. In all these questions, we are doing it as a contradiction method. Like whatever we have to prove it to be irrational. So by contradiction, we are proving it first as rational. And then when we are trying to prove it rational, we got to know that our assumption was wrong. And then by that way, we actually proved it that it's irrational. Okay. So assuming 3 root 2 is rational, then 3 root 2 will be equals to a by b, and then from here you can write that root 2 will be equals to a by 3b. Now if you take this root 2 is equals to a by 3b, I will write it here in step 2 once again, that root 2 is equals to a by 3b. Then as this a and b are integer, you will have to write it down. As this a and b are integer, so this a by 3b will be rational. And so this root 2 should also be rational. But we know that root 2 is irrational, so our assumption was wrong. Okay, so our assumption was wrong, and this 3 root 2 is irrational. So that's all for this video, students. In the next video, we'll come with some new questions. Thank you.